In our previous video, we explored some operator shorthands, and I've been alluding for a long time to the concept of typecasting and some quirks that are encountered with operator division, and we're going to try and explain those today. And these concepts I think, need to be understood somewhat at the same time. So I'm going to break this up into three parts. I'm first going to explain what the division operator does with integers, just integers. I'm then going to explain what casting is, what widening casting is, and what narrowing casting is. And then finally, I'm going to circle back and look at what happens when floats are involved in, or doubles are involved in division. Okay, so let's start with integer division. Java does not round up. If we give it 1 divided by 2, that will not give us 1. It will give us 0. Not 0.5, not 1, 0. And this is quite important to remember, because you'll sometimes maybe assume that Java will round up at 0.5 like we're taught to in maths. But if I just give it 3 over 4, it'll still give me 0. I can give it 99 over 100. And if those are both integers, it's going to give me 0. Now, if I give it 199 over 100, it will give me 1. But the point here is that it rounds down. Now, this is division with uniform types, with integers and integers. But before we understand what will happen when we use integers and doubles, we first need to take a look at casting. So, what's casting? Well, the simple answer is casting is where we take a variable that has a certain type, and we tell the program, I want to change the type on this. Now, this has two forms, widening and narrowing. As we've discussed in a previous video, every variable has a range of values that it can take on. Every variable type does. And widening casting is where we take a variable and we cast it to a new type that has a larger range. So say we had a byte variable and it was 127. We could cast it to an int, and we're giving it a wider range. So there's no potentiality of data loss. And we can just write this. We can just write, say we have byte 1 equals 127. We can just write int to byte equals byte 1 without the need for any casting, because it's a widening operation and there's no scope for data loss. However, there is also narrowing casting. Say I wanted to take a double and cast it to an integer. Doubles have a nearly unlimited range of values they can take on. But ints have a relatively restricted range. So there's a scope for data loss here, and it's very easy to understand why. If I have the double 1.5, I'll lose the 0.5. And obviously we've understood that that'll round down in the past. But we just need to know we're losing data here. And what Java makes us do to make sure we know we might be losing data is insert in brackets the type we want to cast to. It doesn't automatically downcast. It asks you to understand that you're downcasting or narrowing. Now, it's worth noting here, if I try and cast D, that doesn't change D. D retains its type. Just as if I take A, say I were to do I1 equals the variable A we've defined up here, A plus 1. A doesn't change here, but I1 becomes A plus 1, but A is still A, right? Casting is kind of understandable as part of an expression here, though. So, what does this mean? Well, when we're dividing 1.0 by 2, Java is automatically casting 2 to a double, because one of these elements is a double. So it understands that we want to do floating point division, not integer division. So it tries to cast 2 to a double, which is a widening operation. So it doesn't need any kind of brackets or anything. We don't need to go in and say double. Java does that for us. And what happens here is because 1.0 and 2.0 are now both doubles, this will yield 0.5, as will this. Because as soon as you involve a double, Java assumes you want to widen everything, unless you tell it otherwise. The way we can illustrate this is do 0.5 plus 1 plus 3. And Java, I don't know if it applies to plus operators, but if those are divisions, it'll definitely assume you want to cast all of them to doubles. Let's find out. Whereas if we did system.out.println int 0.5, which is a narrowing, which is why we have to make it explicit. Now let's just see what that yields. Now, I've done the typing wrong there. Let's see what that yields. So, here we've gotten 4, because Java has tried to cast 0.5 to an integer, it's rounded down, as it always does, to 0, and it's just added 1 and 3. Whereas here, because there's a single double or floating point number involved, it's assumed we want to cast all of them to a floating point, which is a widening operation, so there's no explicit signage needed. And it's done the same thing it's done here. And as you can see, all of these resulted to 0.5. In summary, in this video we covered casting, some of the automatic casting that Java does and doesn't do when floating points are involved, and the basics of integer and float division. You will often see questions where there are no floats involved in any division or addition, and you need to remember that you're rounding down. And sometimes you'll see questions with floats involved, and you need to remember that when an operator, an integer, has an operator with a float, when there's an expression involving a float, that expression will assume you want to cast all other values in the expression to a floating point. Now in our next video, we're going to be covering operator precedence, and this is going to delve a bit more deep into all of the different outcomes your code is going to give you when you try and jam in all these different operators and all these different types. And this is really important because you'll often find questions where you're asked to figure out what the compiler is going to evaluate an expression to. And you'll need to know the order in which Java uses these operators, as well as, of course, what Java does when operators are used, and what Java does when operators are used on variables with various different types. Anyway, that's all stuff for the next video, though. Thank you for listening.